sky.
Hey there, we were making burritos and it looks like we made a little mess. I guess we'll have to throw it in the wash.
Anna, have you actually ever wondered how soap works?
I think it's all thanks to the magic of organic chemistry.
Well, in order to know how soap works, we first need to know how soap is made. Itself does not have the ability to clean off oily grime and organic soiling. Therefore, to remove this, we need soaps and detergents.
The ingredients for making soap is a molecule called triglycerides, which are esters of fatty acids. Are surfactants. This means they reduce the surface tension of water, allowing it to interact with oil and grease more easily.
Soap is made by a process called saponification. This is the start of organic chemistry in action. This is the process where a triglyceride chemically joins forces with a strong alkali to fight grime. Or, simpler put, saponification is ester hydrolysis promoted by a strong base.
The triglycerides in saponification are the reactants, having long hydrocarbon chains that when heated and mixed with a strong base produce soap. In the breakdown of this, we are taking a free fatty acid and reacting it with a strong base to end up with a product of soap and water. What we have synthesized then is a long hydrocarbon chain, which is nonpolar attached to a polar head.
The best of both worlds is seen in this product. The triglyceride tail of the soap molecule is hydrophobic, which allows it to attract dirt and grime. The alkali head is hydrophilic, which allows it to attract dirt.
Majority of food stains are oil-based. Oils and fats are nonpolar. Knowing that like dissolves like, what do you think that this characteristic of polarities could mean? Since like dissolves like, these oils are attracted to and dissolved by the long nonpolar hydrocarbon chain of soap.
The soap molecule comes in contact with grease and grime. The hydrophobic tail attaches itself to the dirt. The soap and oil huddle together away from the water in the washing machine, and the non-polar tops of the soap form a shell around them. This hydrophobic ball of soap and oils in the middle, with a hydrophilic shell around it, is more commonly known as a micelle. The oils are trapped in the micelle and then are washed away in the rinse cycle.
When dirt, oil, greases come in contact with the soap molecule, the hydrophobic tail attaches itself to the dirt. Once the soap grime mixture is released, it remains suspended in the water and it is washed away when you rinse it with clean water.
Of saponification isn't just applicable for doing laundry. It's the underlying chemistry behind how soap works in general. The same principle applies to loofahs that you use in the shower.
The poofs loosen and remove dirt from your skin, making it easier for soap molecules to trap it in their hydrophobic core. Thank you, organic chemistry, for saving our clothes. Organic chemistry really is cool.